All right, class. This is section 4.7. Talks about the identity and inverse matrices. So I guess starting off talking about the identity or the identity matrix. For a 2 by 2, the identity matrix is 1, 0, 0, 1. And that kind of goes for all identity matrices, is where down a diagonal of 1s and then the rest are zeros. Okay, so what does identity mean? Well, that means if I take this matrix and I multiply it any times any 2 by 2 matrix, I'm just going to get this matrix back. And so, it's either way. So that means I could actually multiply it. It's commutative when you multiply it times the identity. So, and it just equals AB times CD. So it's commutative, so you can flip-flop it, and oops, I'm off the screen, but it's just there, better. All right, so no matter what, you multiply these, or you multiply it this way, it's just going to equal, you're going to get the same matrix back, and that's what an identity is. It's kind of, if you relate it to multiplication, what's the multiplicative identity? Well, it's 1. You take any number times 1, and you get that any number back. So what's the additive identity? Well, it's 0. You add anything to 0, you get that same number back. So this for matrices. Is this particular matrix. Okay, now for a 3 by 3, then it's similar. It's along the diagonals you have 1s. So I take that matrix, or this matrix here, times any other 3 by 3 matrix, then it's the identity. So I'm not actually going to show you an example of that, because that's just the rule, or that's the definition of identity. The next thing we talk about when we talk about identities, we also talk about inverses. Okay, so when two matrices are inverses of one another, the way that you know that is if the product of them.
Line 1. Ms. Hobbs, line 1, please.
The only way that you know that they're inverses of one another is if the product of the two matrices equal the identity. So, for example, and this is some notation here. So if I have matrix A times matrix, or the inverse of matrix A, this is matrix A, and this is inverse of matrix A. This is notation, so it's a little bit different. It's not a negative exponent or anything like that. This tells me that this is the inverse of matrix A. So I have A times the inverse of matrix A should equal the identity matrix, okay, or whatever it may be. And we just started talking about the identity matrix, so you should know what that looks like, whether it be a 2 by 2 or a 3 by 3. All right. So, well, here's an example. I want to know if matrix these two matrices. Let's see, matrix X is 3, negative 2. Negative 1, 1. Matrix Y is 1, 2, 1, 3. I want to know if these two matrices are inverses of one another. Okay? I want to know if they're inverses of one another. Well, the only way to figure that out is if I take the matrices, and I multiply them together. Okay, so I don't think there's any particular order here that it really matters. So I think if I just took matrix X times matrix Y and see what happens, and see if I get the identity matrix. So let's see what happens when I do that. So I'm just going to take this matrix, I'm going to put it up here. And I'm going to do row times column. Try to do some of this in my head here. Row times column, I get 3, plus negative 2, I get 1. Row times times column, I get 6 plus a negative 6, I get 0. Starting off good so far. Row times column, I get -1 plus 1, that's 0. Row times column, I get -2 plus 3, which is 1. Notice that this matrix times this matrix equals the identity. Therefore, this matrix and this matrix are considered to be inverses of one another. So that's how you kind of determine that. Now, this concept is going to be we're going to be able to apply this here later on in another section or two, to where we can solve matrix equations, and that's going to be kind of important. So understanding identity and inverse matrices is really, really important. So, all right, another concept added on to the 4-point set. Well, I mean, it's very similar to inverse. Okay, I want to give you an example of just finding an inverse of a particular matrix. Okay, so say that I'm giving this matrix here, we'll call this matrix A. I want to find its inverse. I want to find A inverse. Okay, to do that, they actually they've derived a formula for us, or an algorithm here, to to find that. So it's really not that difficult to find. So if this is matrix A right here, remember the relationship between A and A inverse. If I multiply those together, I get the identity. Okay, but in this goal, I want to find A inverse. So A inverse equals 1 over. If you remember this right here, this is actually the determinant of a 2x2 matrix, because I'm going to multiply A times D, and then I'm going to subtract the product of B times C. In this particular situation, I get -1 times -2, which is 2, minus the product of 8 times 0, which is 0. And eventually that's just going to simplify to 1/2. Now, all I have to do is just kind of fill in here how the matrix gets flipped around. Notice this diagonal gets flip-flopped, so A goes down here, D goes up here, and then on this diagonal, it's negative. Okay, I just take the negative of B and negative of C. So let's do that to my original here. So I flip-flop, so -2 is going to go right here, -1 is going to go right here. I take the negative of 0, which is just 0, and I take the negative of 8, which is going to be -8. So now I end up getting this. Now to finish it off, I have to do scalar multiplication here. 1/2 times each individual element in there. So to do some mental math, 1/2 times -2, I get -1. 1/2 times 0, I get 0. 1/2 times -8, I get -4. 1/2 times -1, I get -1/2. So right here, I just found my inverse matrix. So again, if I take this matrix times this matrix, I should end up with, the identity matrix. Okay, that's just just a heads up. So this is fairly important to be able to find that inverse matrix. All right, I'm gonna have some try this problems and see where you get. All right, here's two try this problems right here. Okay, the first one says determine whether they are inverses. So is A and B, are they inverses of one another? Okay, or is A, could I call this matrix A inverse? That's the question. So that's something you have to figure out. And then question number 2 here, it says find the inverse of this matrix if it exists. Okay, so that's something I didn't quite explain real quick. I'm not going to do that now. And that's if you have one, remember part of the formula where you had 1 over AD minus BC times, the matrix here. Now, if this determinant ever this determinant, if it ever became 0, then the inverse would not exist. Okay, it wouldn't exist. So that's what you would end up writing. If this expression were to ever to be 0, then the inverse would not exist. Okay, if that were 0. Okay, so this kind of heads up on that. All right, so try these problems and see where we can get. Thank you and have a great day.